Welcome everyone. Uh, as you know, Lukmaan IAS is running a series on GS economy. So today, what I plan to do, I will discuss one important PYQ. Although we have already discussed CSP 2023 paper, but there was one question on beta. Right? UPSC asks what is beta. Now it is very according to my view, as far as I understand finance, how a UPSC aspirant will know what is beta. And to do well in GS mains, in GS economy part, you have to have the good understanding of economic surveys. But to understand economic surveys well, you must know some quantitative tools. Let's say even if there is a student from humanities, they must also know these quantitative tools. And the purpose of this lecture is to share something about those quantitative tools in very simple terms. Let's say when you read a economic survey, you face things like what is mean, standard deviation, what is covariance, what is correlation coefficient, and this year in paper you find beta, and sometimes they also talk about the regression analysis. Okay, regression analysis, and see. One more important thing you must understand. Let's say you qualify this exam, you join services. Your understanding of economy has to be very, very good, irrespective of what department you are working. The people who have good understanding of economics, those who are good in finance, those who are good in mathematics, according to me, as far as I observe, they are given better postings. So you cannot go away. You cannot leave this thing. So let's first see this question. What was the question? This question came, this is 2023 paper, in the context of finance. Question number 73 of Saturday. 73 of Saturday. Let me just enlarge it. Okay. So what it says, in the context of finance, the term beta refers to. Now, you see the four options. The question is like this. You know it, you don't know. So generally, what is beta? Beta is nothing but what you study in class 10, that is slope. That is called tan theta. Right? Tan theta is your slope. And what beta tells? Beta tells you the sensitivity. So the D option, the numerical value that measures the fluctuation of a stock to change in the overall stock market. And how it is given? Let me write the formula here. Beta is given by covariance I. Let's say there is a security. I'm assuming there is a security I, and you are seeing its covariance with the market, and you divided by the variance of market. This is what beta is called, and this is nothing but your tan theta. And you know what is this tan theta? This is perpendicular upon base. So and here this is what you are supposed to know. But somebody might ask how somebody will know this formula. And see how you can solve if you are reading newspaper. I will not say even newspaper. If you're reading economic surveys carefully, and you are reading editorial economics editorial carefully. Do not go into news. Too much. Do not. Do not stuff your mind with too many news. Try to stuff with ideas, and those ideas come through when you read editorial, when you read economic surveys, when you read SDR reports, human development reports. Okay. In fact, one more thing I would like to suggest. Let's say urban infrastructure is in your syllabus, GS3 economy. There is a wonderful report written by Professor Ahluwalia. I've forgotten the first name. She was a wonderful economist from MIT, and you must read it. Okay, and she is also, companion of wife of Professor Montek Ahluwalia. So just if you can read those kind of report, and reading those report, you can make a 2-pager on infrastructure. That would be wonderful. Then and see, if you observe carefully, that report is something even a level higher than economic surveys. Now let us move to our tools, which we want to discuss. Before that, let's see this year's economic survey. Right. This is chapter 2 of economic survey 2023. So here I'm reading a paragraph from page number 36. Here they talk about returns to the economic and structural reforms after 2014, right? and shock that economy first. So here what they are talking about? They are talking about mainly how the debt of the how the debt change in the private sector. So what they are saying, non-financial, the India's balance sheet was India's balance sheet is stressed caused by the credit boom in the previous year. Uh, Due to this was a culprit, and due to this, the growth which was expected in the last 80 years did not happen. This is what they are claiming. And then they are talking about non-financial private sector debt increase from 70 to 9% to 1136. So this you will understand. But let's say you come to this line. Now they are saying a statistically significant negative correlation between the gross NPS. Yes, no? Gross NPS. You know what is NPS, and credit growth shows that the bank's credit supply was severely constrained due to stress in their balance sheet during the second decade. Twine balance. You must be knowing twine balance sheet problem. What was there? Banks banks were also in trouble. They were facing lots of NPA, and the corporation, they were also highly leveraged. So see, when I use the word leverage, it means high degree of debt. Debt to equity ratio is very high. See, your debt to equity, rather I should write debt to value, right? Debt to value, and value is equal to equity plus debt. See how you can gather money to run a business, either through equity or either through debt. If your debt to value ratio is very high, this means your leverage is very high. And leverage is like see, if the company's return is more than your market return, then leverage is good. But let's say if it's other way around, then leverage is a big problem. So, and this idea we will discuss some other day. Here my point is, do you see the word correlation here? Can you make out something? Let's say somewhere you see regression line, economic survey. So it is not. I don't say that without this you cannot qualify UPSC. But if you understand these tools, your ability to understand economic surveys will improve, and so your mains answer will also improve. So let me discuss a few economic tools. We will start with mean. Right? Mean is, you simply know, mean is nothing but average. Right? When I say average, so let's say it is denoted by, let's say there is a population. It's a big population. You take, this is population. I take one sample. I took, this sample, and I take, let's say in this element are 1, 2, 7, 9 something. Right? I will add them and take their average. This is called mean. If I take the average of full population, then I will indicate it by mu. That is nothing but your population mean. Okay, so you understand this is nothing but average. So whenever you see mean, you have to tell yourself it is a average. Okay, then let's say median. They are talking about median. Median, what you do? You take the numbers and you arrange them ascending or descending order. Let's say number are like 1, 7, 5, 9, 13, right? So what you will do, you will arrange them 1, 5, 7, 9, 13. Your median would be 7, right? This way you will call it median. Sometimes they also give you group data, class interval data, right? So from there you can also calculate mode. Mode means the data which is occurring highest number of time. Let's say this data is there. So in this data, 13 is occurring twice. 13 is occurring twice. So your mode is 13, right? So you understand mean, median, mode. You must also know standard deviation. Standard deviation. Let's say there is some data. I'm calling it, let's say this is X. Numbers are like 1, 3, 5, 7. You have to calculate the standard deviation. So first what you will do, standard deviation is given by this. See, standard deviation is, variance and standard deviation are related. Variance is square of standard deviation. Standard deviation square. Fine. So how you calculate variance? This is the symbol of variance. It is given by sigma and summation of xi means first element, right? Minus mean. Mean, you can easily calculate the mean divided by n. Let's say what I will write here, how I will calculate. My first element is 1. My mean is 3, 4, 9, 9 and 16. So mean would be 4, right? So my mean is 4. I will take the square. Then 3 minus 4 square, right? This is nothing but the second element. Second element minus mean. Then I will write the third element, 5 minus 4 ka square. 5 minus 4 square. Then 7 minus 4 square. What I'm doing? I'm just simply from the first element I'm subtracting second, mean, and all this I will divide it by number of elements, that is 4, because there are 4 elements. So this will give you variance. This will give you variance, and when you take the square root of variance, you get this number. This is called standard deviation, right? See, that is fine, this formulation, but you have to first feel what is standard deviation. Let me help you visualize. 1, 3, 5, 7. Let's say somebody says this is last 4 years GDP data, and you have to tell and somebody says standard deviation is so and so. So what should come to your mind? I'm assuming that you are a student of, let's say, sociology, literature, all right, and first you are reading economic survey, you're in services, and you want to know, you have been given this is GDP data for let's say 4 years, and standard deviation. So standard deviation is, let's say, some value is there. So you know what is the mean? Mean is 4. Just now we calculated, right? So what it means? From the mean, the first number is how far? 3, right? Second number is 1 distance. It is 3 away, but in the negative side, no problem. You have to take the, that absolute value. Here it is 1 distance away. Here it is 1 distance away. Here again it is 3 distance away. So what you are taking that difference, the distance, the distance between these mean and these numbers, you are squaring them, and then you are taking the average of that. See, that's what you did, right? Xi minus x bar whole square upon n. And for standard deviation, you will take a square root of. So how you will say? You first calculate the mean. From the mean, you are checking the value of each year's GDP data, and you are taking a square of that, the difference, and then you are taking kind of an average of square of difference, right? Average of square of difference. Then you are taking a square root that indicates your standard deviation. Indirectly, you can say that how much you can even call it variability, right? Variability. It indicates variability, right? So this is important. Now there is a big statistics theory of that variance are additive. We cannot go into that. But yes, I want you to know at least this much, so that you can read economic survey carefully, and not only reading, right? So once you join services, or when you're attempting CSET, all these techniques will help you. Now you have understood standard deviation, variance. Now let's say somebody asks you what is covariance. Covariance is also given in some, let's say there is 2 series. In what is the covariance? We indicate covariance by so on. Let's say this is X series and this is Y series. X, let's say I'm calling real wage, and this is employment. Right. Why I've written real, not monetary? That has a meaning. When we will discuss economic survey, then you will understand. But for the timing, let's say this data is like this: 2, 5, 6, 4, 1, 3, right? 8, 7, right there. Can you see? Let's say this data is increasing. It is moving from 2 to 6, but let me make it 9. This is also increasing. This decreased by 5. This data is also decreasing. This again increased. This also increased. So what is happening? You can see a pattern. When x is increasing, y is also increasing. Let me show you another series. Same. I'm calling it x1, y1. Number is like this: 2, 5, 6, 1, 1, 5, 8, and then 7. Here what is happening? 2 increased to 6. 2 is x is increasing, but y is decreasing. Right? They are in now opposite direction. Here again x is decreasing, but again y is increasing. Can you see the force? So when you take the summation of this, here what is happening? If x is increasing, y is also increasing. So you can see the force is acting in the same direction. Here, sometime let's say x increased, y decreased, x decreased, y increased, x increased, y also increased. So here two forces are acting in the same direction, one force is acting in the other. So when you take the cumulative, combined effect of all these forces, that gives you kind of a covariance. I use the word kind of because it is not exactly that. So how do you calculate it? Let's say there are two series. So what you will, how you will calculate? I will write it here. So just a minute. Okay. So you can see this, right? Now covariance x, y, they are two elements. It is given by xi minus x bar, that is mean, into yi minus y bar, right? So upon n, right? This is your covariance. And let's say the series. For example, let's say you have to calculate for this series. So what you will do? You will write covariance of, you will write like this: covariance of x comma y would be, you will take the mean. 2 plus 6 is 8, 9, 9, 17, 17 by 4. Okay. So first number will be 2 minus 17 by 4. Right. Then you will multiply to y minus y1. Y is 5. And this element, 9, 5, 14. 14 is 17. 17, 24. 24 by 4, 6. The mean is y bar is 6. So I will write that its mean is 6. Its mean is 17 by 4. So this is first element. Then you will do for the second element. 6 minus 17 by 4 into 9 minus 6. And this way you will do for remaining two elements. Now you got it? So now you have understood covariance. What is covariance? Now, see, once you have understood this covariance, now generally covariance is not used much. What is used is correlation coefficient. This we indicate by rho xy. And what its formula? Its formula is nothing but the covariance xy upon standard deviation of x and standard deviation of y. Now you might be, you might have a question that if we already know the relation between how x and y, if the x is changing, how y is changing, then what is the effect on y through covariance, then why we need this thing? See, the only difference between this and this is it gives you a standardized result. Let's say here your x and y values are in thousands, and your these values are in unit digits, here in 1000. So the covariance value would be here, right? The covariance, when you will calculate covariance for this table, it would be much larger. It would be, let's say, in thousands. Let's say I'm assuming it is 1000, and here the covariance might be, let's say, only 3. So would you say that the covariance of this series is almost 333.333 times of this series? No, because here the unit digits are in thousands. So here the numbers are in thousand, here the numbers are in unit. So when you divide the covariance of this series by the standard deviation of x and standard deviation of y, and similarly for this series you divide by standard deviation of x1 and standard deviation of y1, you get a number. Now you can compare the correlation coefficient of this series and this series. I'm indicating this series correlation coefficient by, let's say, rho x1 y1. Now they become comparable, let's say, and you must know, even Economic Survey has mentioned. See, just now we read that statement, that what it said, let me read it again. What it says, a statistically significant negative correlation between the gross NPAs and credit growth. So now let's say you have to understand what it means. So let me just remove this part. Or what I can do, I can take it off, right? Okay. So now here X is your they talked about gross NPAs and credit growth, right? Credit growth. So, and they said the correlation coefficient is XY is minus 0.5. Now you have to visualize it, what it means. So if you have this understanding. So what it means to say, if your gross NPA is increasing, let's say, if your gross NPA increase from 1 year to another year, so what will happen to your credit growth? It will see, let's say I have a series and its correlation coefficient I'm getting negative. Then what it means? It means I can say that if X is increasing, Y is decreasing, and if Y is decreasing, X is increasing, because they are acting in the opposite. The forces are acting in opposite direction cumulatively. Okay. So this is this is a problem for So whenever your gross NPA will increase, your credit growth will decrease. So that is what they are trying to say. So if you have this understanding, if you understand, okay, how the correlation coefficient is derived from covariance and what is the meaning of covariance, and before that you understand what is standard deviation, what is mean, so that will complete your picture. And you will immediately understand a statement like this, and you cannot go away from this statement if you are, if you are to join services, because not only in examination, even in future, you have to read a document like this, policy document. So you have to know this, right? Now let's come to the beta question. Now beta, see what the beta is. Beta is given by covariance Im upon sigma m square. See, beta is nothing but slope. Now I'm looking the covariance between I am calling it, let it security. Security means any bond or any debenture you have purchased. This are calling I, and this is M. Let's say your return on security is 10%, 15%, 20%, 15%, 0%, and market return is, let's say, 15%, 7%, 8%, 20%, 7%. Okay, this is the market return. This is so what beta is telling you, how it is. What is the sensitivity, right? What is, let's say, if I changes, so what is the change in M? And this is given by this formula. This denominator is nothing but your variance of market. And how you calculate it? From this series. Covariance how can calculate? From using both these series. And let's say if I say my beta is 1, what it means? Beta means if my security is, my market is increasing 10%, my security is also increasing 10%. Let's say if my beta is more, so let's say beta is 2. So what it means? If my market increases 100%, my security, the change in my security will be 200%. But if my market goes 100% down, my change in security will be 200. So it is very, very sensitive. That sensitivity, tan theta, see what tan theta tells you? Sensitivity only, right? If you increase perpendicular, how your base will change. So same thing, class 10 geometry only, but applied in. See, now so far I have covered this. this is my view that maybe in future, let's say you must know what is portfolio. Okay, since UPSC asked beta. Okay, this year they also asked what is the which of the actually they gave 4 options and asked which is the part of your capital market. So I would suggest you to do one thing, and this is my observation. Many questions are coming from a particular PDF. What you do? Go on Google and just search this financial market. Okay, financial markets NCRT. You'll find a PDF. It's a chapter, I think, class 11th or 12th book. And there you will find categorization of capital financial market, right? Capital market, money market, short term, right? Money market. And this is capital market. Capital market, debt or equity, debt and equity. Here also primary. Okay. So what I meant to say, this is for short term, right? I cannot take this thing here. In the lecture I will read, but I want you to read this PDF because this is my view that whatever, if UPSC has something related to, let's say, beta market, everything is covered in this PDF. Okay, in this chapter of NCRT. Maybe in some lecture I will discuss that. Now, maybe, I want to tell you something about portfolio theory as well. Now, see, now it is a very, there are so many people have invested their life to study this topic. But UPSC will then, why UPSC will ask any, technical concept? But what they can ask, let's say what happens when you apply, there are, let's say there is a risk-free instrument, risk-free financial instrument. Risk-free means you can invest in that and you will get guaranteed return. Let's say treasury bills. Treasury bills we generally assume are risk-free. But let's say there is another security, RI. Here it has a risk and return. This is I'm calling return, and risk will be indicated by standard deviation. So it has the risk and return trade-off. So what it means? If the risk is more, the return will be also more, right? So you have to understand this. Return and risk always have a trade-off. Now, what you have to understand, whenever you mix different securities, see, listen carefully. You need not to understand, read finance, but this concept you must know as a, administrator or as an UPS aspirant. When you mix 2 securities or 3 securities, or maybe number of securities with a risk-free rate or without a risk-free rate, the overall risk of those securities might be reduced. And why it get reduced? Now, there is some mathematics involved, but in simple terms, what we can say, let's say there's a Reliance security. Let's say Reliance, we will call it Tata Foods. There is a company like Tata Foods, but let us create it. Tata Foods, and let's say ABC, let's say games, right? And we are assuming that the correlation, now you understand the word correlation, the correlation between them is very little. Whereas, let's say XYZ food processing, it will have high correlation with the Tata Foods. So what happens when you mix, let's say you're trying to mix the 3 securities and their risk is, let's say, 0.5, 0.6 and 0.4. If you mix these 3, it is not necessary that their risk will increase. What I mean to say, it is not necessary that their risk will become 1.5. No. Sometimes what happens, their risk may nullify each other. Let's say some stocks goes up, another stocks come down. So that is how you can diversify a risk. So this is my view. UPSC may sometime, maybe in future, maybe in they may ask what is diversifiable risk. This, let's say, what is their trend? They ask, they give you a phrase. What do you understand by this? This year they ask about beta, sterilization. So similarly, they will ask you, what do you mean by diversifiable risk? And undiversifiable and non-diversifiable risk. Risk. These two terms you must know as an aspirant. What it means when I mix many, let's say I'm making a portfolio. Portfolio means in portfolio, what you do, you mix many securities together, and you make a portfolio like. See, I cannot tell you exactly, every detail here, but portfolio looks like this, and this is called your efficient frontier. Efficient frontier. Here, this is your standard deviation. Here, it is your return. Okay. And what it mean to say? Let's say there is another security here. For this particular amount of risk, how much return you are getting? You are getting this much return. But if you keep this security, if you take the security to this point, so this is always more efficient because for the same risk, you are getting more return. So that's why it is called efficient frontier. You will try to keep all your securities here. And what you do in portfolio? In portfolio, you mix many securities together so as to reduce diversifiable risk. Diversifiable risk means the risk which can be eliminated by choosing security in such a way that they are not correlated. They are independent. So that is called diversifiable risk. And how portfolio manager or traders, how they reduce it? Just by mixing many securities. And for this, they are not paid. This even, a layman can also do, although it will take time for a layman to understand all those things. But yes, for this, they are not paid. They are paid to manage undiversifiable risk. What is undiversifiable risk? The risk which is inherent in the economy. Let's say inflation, right? Interest rate, exchange rates. So these risks you cannot diversify. These are undiversifiable risks. These are also called systemic risk. Systemic risk. Systemic, it is in the system. Okay. So this is what I have to suggest. I hope you like this lecture, and we will continue our GS Economy series, and we will discuss more questions. Thank you very much.